Hi, I'm Mrs McTaggart. In this video, we're looking at the topic of differentiation, and in particular, how to find the equation of a tangent. Now, the equation of a tangent appears a couple of times in the higher math course. It appears in quadratics, but I don't teach you the quadratics method. I'll wait till we've done differentiation and do this method. It will also appear in circle, and it's got a very similar kind of format to it. So before I start, I just want to, I use this little diagram a lot. There are so many different questions you're going to see that help you decide when you're doing differentiation. And the buzzword we're looking at today is focusing on this one down here, gradient of a tangent. So any mention of tangency, gradients, equation of a tangent, we have to recognise now that that stands for differentiation. So to find the equation of a tangent, you need to remember a tangent is just a straight line. And whenever you do a straight line, you need two things. You need a point, a gradient, and then you can get your equation. And I always use the kind of layout that I write down point, I write down gradient, and I write down my equation. And that's my general layout. And it also helps prompt you to think, right, what do I need to do? Because sometimes people will do one bit and not know where else to go. So the point, they will probably always give you an x value. If you're lucky, they might give you a y value, but you might have to get that through substitution. Okay, so substitution into y or f of x. The gradient, now, differentiation is another way of finding gradient. dy by dx and m stand for the exact same thing. Well, so does f dashed x. So they all stand for gradients. Remember, the differential of an equation, if you've got an x value, can get you the gradient of the tangent to it at the time. And just remembering what a tangent is. A tangent to a curve is if you have any kind of curve, a tangent is a straight line that meets it in one point only. And then once you've got your point and your gradient, you can get your equation. So let's look at some examples. So question 1, we have to find the equation of the tangent to this curve when x equals 2. So remember, equation of a tangent, I'm in the habit, any kind of straight line question, I always write out the 3 steps. I write the point, I write the gradient, and then I write the equation. And it's just a good kind of habit to get into because it helps prompt you into what you're going to do next. Because a tangent is a straight line, so it's reminding you what to get. You need to get a point. Now, we already know part of the point is when x equals 2. So we need to go get the y part of that. So what we're going to do is we're going to sub in 2 to the equation. So we're going to have 3 times 2 cubed. Take away 4 times 2 squared. Plus 9. So 2 cubed is 8 times 3 is 24. 2 squared is 4 times 4 is 16. And then add on 9. So what we've really got is 24 take away 16, add on 9, which gives us 17. So the coordinate we're going to use is 2, 17. To get your gradient, what you do is you find f dashed x or dy by dx. So in this case, we're going to use dy by dx. And we're going to differentiate the equation above. So times by the power, lower the power, will give you 9x squared. Take away 8x and the 9 will disappear. Now dy by dx means gradient, so I'm going to replace that with m for gradient. And we know our x value is 2, so we'll replace x with the value of 2. So there's a lot of substitution going on in here. 2 squared is 4, times by 9 is 36, take away 16 gives us 20. So now we have enough information to go at the equation of a line. We're going to use our gradient of 20. And we're going to use our coordinate of 217. So the equation of the line, if I just make myself a wee bit more room here. Now I'm going to try and fit it up beside it. So it's going to be y minus b equals m bracket x minus a. So y minus 17 equals 20 bracket x minus 2. I need to get a better pen. And if you multiply this out, you have negative 40 here, and take your 17 over, so 20x, that will become add 17, so negative 23. So this is the equation of the tangent when x equals 2. So this is a really common question. You'll see this quite a bit. Okay, let's have a look at example 2. This is a different font. I've literally ripped this straight from my past paper. So in this one, we're to find the points on the curve for which the gradient of the tangent is 15. And once we've done that, we have to find the equations of the tangent is at these points. So let's have a look at what we get. First of all, I want to multiply that quadratic out. So let's start by doing that. So we've really got y equals x cubed minus 6x squared. Okay, so to find the point of contact when the gradient is 15, so they've told us a gradient, so we need to get an expression for the gradient. So we need to do dy by dx. So let's differentiate that, and it gives us 3x squared. Take away 12x. Now, this dy by dx stands for your gradient, and we've been told that the gradient is 15. So we can replace that with 15. And I'm going to bring the 15 over and make it equal to 0. And this will give us minus 15. And before I factorise, there is a common factor of 3 here, which will make things a wee bit easier. And this will give you x, well, it's going to be a 5 and a 1. And to get minus 4, it's minus 5 plus 1. So you end up with x equals 5 and x equals minus 1. So we have two tangents, one with when x is 5 and x is minus 1. So what I'm going to do is at this point, I'm just going to go get the two coordinates right now. So I'm going to create a little bit more extra space. So to get the y coordinate, I'm going to plug in the number 5. So this would be 5 cubed minus 6 times 5 squared, which is 125 minus 6 times 25 is 150. So I've got minus 125. So one of my coordinates, I'm just going to write it up here, is 5, negative 125, with a gradient of 15. And the other coordinate, I'm going to plug in x equals minus 1, so y equals, so it'll be minus 1 cubed, minus 6 times minus 1 squared, which will be minus 1, take away 6, which is minus 7. And the other coordinate is, what did I just use there? Minus 1, minus 7, with a gradient of 15. So I have to go get the equations of two lines using each of those coordinates and each of those gradients. So let's do the first one. So what I've done is I've just brought my information down here, and we're going to go get the equation of each of these. So for the first one, I would have y plus 125 equals 15 bracket x minus 5. Y plus 125 gives me 15x minus 5 times 15 is 75. And then bring that 125 over. I would have minus 200. So here's the equation of one of my tangents. And the second tangent would be using the other coordinate. So I'd have y plus 7 equals 15 bracket x plus 1. So y plus 7 is 15x plus 15. Bring that 7 over. You get yourself 15 take away 7, which is 8. So we have found the points of contact and the two tangents. So this one is, this is at the point minus 1, 7, minus 7. And the blue one was at the point 5 minus 125, which is what the question wanted. They wanted the points of contact and the equations of the tangents at these points. Job done. Okay, so not too bad. It's just recognising that the minute they talk about tangents and gradients, that you have to differentiate, and that remembering that dy by dx is another alternative way of writing m for gradient. Right. Okay, and then let's go with the final example. This time we're to find the anti-clockwise angle between the tangent to the parabola y equals x squared plus 3x plus 2 when x equals 3. So any mention of anti-clockwise angles or angles in straight lines is going to be using m equals tan theta. But to do that, I need to find the gradient when x is 3 first of all. So we're going to differentiate dy by dx. and we get 2x plus 3. I'm going to change dy by dx to m for gradient. We know x is 3, so we're going to do 2 times 3 add 3, which is 9. So my gradient is 9. So then if I do m equals tan theta, I can replace that with 9. And then theta will be inverse tan of 9, which gives us 83.7 degrees to 1 decimal place. And that's all my examples on finding the gradient of a tangent or equation of a tangent to a curve. I hope this has helped. Thanks for watching. Bye bye.